Hey guys, it's Vince with Mastering the Method, and today you can see I'm inside of Makerbot Print, and I'm just checking on a batch print that I've been working on. Many of you know that I've switched over to BuildTak's build plate, and I wanted to tell you that I actually switched back to the stock laminate. And again, this is really interesting results. You can see here I did increase my chamber temp. I'm running at 59 degrees Celsius, and I've actually set it to 60, so we're right on the money, close. And what we're talking about here is being able to do batch printing of small parts with small footprints. And you can see here these are all still standing. Now I want to show you why I switched back to the stock laminate, so that hopefully you guys can do your own comparison, but I can show you exactly what I had happen to me, and I want to see if anyone else has actually had this happen to them. This print, I believe, knock wood, is going to be successful. We got about an hour and 39 minutes left. These are just spacers, but once again, when you're printing small footprint components, especially when you're printing them tall directly on the build plate, naturally you want to make sure that the print is completed without knocking anything over, or it could be catastrophic, especially since we don't have a sensor to dictate turning the machine off or stopping the machine if something moves. So these are things that we must pay attention to, and I look forward to showing you exactly how the print is going. Okay guys, we're in front of the method, and you can see once again, as I stated earlier, we are now printing on the stock laminate. I changed over. I have multiple build plates, and I just went and laminated it with the stock laminate. And I want to show you why I did that. Once again, we're at 84%. Got about an hour and 37 minutes left. This is looking fantastic. Show you exactly what I was experiencing. And this is something I want you guys to pay attention to on your build plates. Let's see if I can focus. There we go. Now you can see where the spacers were being printed. And it's not uncommon to get some actual contact points where the glue will turn white. That makes total sense. What doesn't make total sense is where we have indentation happening. I'm trying to get on an angle so you can see that. It's actually making more or less a dot where the hole is for the spacer. And when I say that, it's actually embossed it. You can feel it. So if you have your build plate and you can actually run your fingers over and you start feeling indentations or tracings of where where the nozzle is actually laying down filament, what it's really telling you is the material that you're printing on is not able to tolerate that temperature. I do not know why we would have that only in specific areas when, of course, the nozzle's fluctuation is not much, but you can definitely see they're forming right there, right there. This one's real pronounced. Over here is not so bad, but right here we're starting to get that. And what typically will happen is if you print directly on the build plate, you're going to find that if you print any components in that area, it's very hard to get that component to stick fully because, again, with an embossed area, you have a raised section, which is what that little dot is, like a zit, and then you have the lower portion of the laminate. And therefore, you're off slightly when you actually go to print on that. So these are things to be careful of. Not sure why this material did that. It's rated, I think, to 120 degrees Celsius according to what's read online, but again, it's really weird that it did it in one spot and no other area. And of course, calibration was done with the assisted leveling prior to every print. Temperature setting on this, as far as nylon carbon fiber, is 260. So again, the filament touching the build plate, you have to ask yourself, when these vendors that sell this material are selling it and they say that the laminate can withstand a certain temperature, are they identifying that as a heated temperature, or are they identifying that as a temperature that you can print on? at a specific temperature, because I find that hard to believe that this would withstand 120 degrees Celsius when, when you're actually applying hot filament to it, it's just basically going to melt it. So I want you guys to be very careful with that. And again, it really becomes more of an issue on smaller prints. And I believe my personal experience is that on smaller prints, when it's more concentric of an area, it just keeps heating that area over and over and over again. And as that occurs, it basically melts. And you can see exactly what I'm talking about. You want to be careful with this material because, like I said, if it's not perfectly smooth, it's going to transfer all of that in terms of any area that's raised to the bottom of your prints, and it will definitely make their adhesion much less. So be careful with that and pay attention. If you start noticing this forming, you want to have this. This is okay, totally smooth. If you start feeling it and you can feel that emboss area, it's time to be cautious of your build plate. Now again, if you're printing on a raft, you might be okay if you go wide enough, but keep in mind you're still going to have a loose section. It's not going to print totally flat of the raft. So that can also transfer to your component you're printing on. But I just wanted to highlight this because I think there's a lot to learn here. And again, if I can spend the money and test and hopefully save some of you to at least know what to look for when you're working with it, I think it'll definitely help us all. Okay guys, I want to discuss a test I recommend all of you run when you're doing small printed parts like this, once again with small bases. The reason I feel most print fails when you're actually printing those small components and you have a very small base is because we have G-force that we're trying to dissipate when we print too fast. A real easy way to see the excessive G-force is place a small bottle of water or liquid on top of the printer. Watch it print and watch the water. Any energy transfer you see into that water is being transferred into your base plate and into the components potentially. There's a little bit of shake, you saw it right there. And that is something you really want to pay attention to. Now the method, the one thing you will notice right away is if you turn your speed up really high, let's see if it does it again, you will find that that energy transfer can be all over the place. So much so that the transfer of energy can actually shake your table or whatever platform it's on. Using this method will definitely make a difference in your printing to get that speed set so that you can slowly dial down your speed and make sure that the water or whatever liquid you use to determine any energy transfer is at a minimum. So those excess force from acceleration, deceleration, you can make visible. This is something not really discussed. I don't know why, I've never seen a video on it. But after performing this test, and I do it with a lot of my clients dealing with CNC robotics, the same principle, you can actually see energy transfer. And the idea is just like a car doing 60 miles an hour who slams on their brake. You can see right there we have a little shake. We want to make sure that you come to a gradual stop rather than abruptly stopping, and all that energy transfers all that energy into the people in the car and everything else in the vehicle. So think about it like that. The big principle when you're printing is to make sure that when you change direction, you do not have problems with that energy transfer to your components or your base plate. And you can see those quick movements right there. I actually turned down my speed. I'm going to show you guys my settings because I know I'm going to get a lot of questions on it. And again, these the footprint on these components are only, I believe, a ½ inch. So printing these in a vertical format, any energy transfer, the higher that those print away from the base plate is going to increase the leverage point to where any friction other than down the filament, you're going to find you're going to have problems with them standing. So keep that in mind. Now I'm not going to tell you that using the correct laminate is not going to help, because we know that will definitely help. But the main thing you're paying attention to is that energy transfer. You want to make sure that that liquid does not move. And if it does move, it's very minimal, because a real small part, there it goes, you saw just a little bit of energy transfer. That's what they talk about when they talk about a rigid platform. In CNC robotics, you hear it talked about all the time, Haas mills, whatnot. The more rigid your robot is, the better it can dissipate that excess energy when it changes direction. Well, now, when you place a water bottle on top of the printer, you can see that. So, again, really cool experiment. Just check it out. And again, it will assure that you dial in the speeds correctly. I'm going to cover actually two settings I made that I think really corrected this print. And I hope it helps many of you. Okay guys, I'm inside of Simplify and I want to cover the settings, and there's two of them that I feel really resolve the issue I was having with knocked over parts, and it may certainly resolve any issues you're having. You can come over here to retract vertical lift under your model extruder. You can see I've got it set at 3 millimeters. That's simply going to mean that when it retracts, naturally it's going to raise the head like a Z-hop. That's another term for it, so that the extruder's head will actually come up 3 millimeters. You can arbitrarily set this at what you like. I just arbitrarily set it at 3, see exactly what would occur. Then what I did was I came over Advanced, Require minimum travel for retraction. Simplify does not have a setting, at least to my knowledge, that will allow you to have the extruders actually come up whenever it goes to move to another object. So think about what I'm saying. I'm saying that in a CNC environment, you would actually have on a router or mill the option to do what's known as a safe Z-axis setting. And what safe Z-axis means is that it would raise the Z-axis up so that it would go to whatever arbitrary measurement you've set, so that it's considered a safe zone. So it would not hit parts, it would not crash the machine, that sort of thing. What we do with 3D printing, very similar to the crossover effect, is that we are looking to raise the nozzle up high enough that there's absolutely no way that it would ever interfere or make contact with any of the delicate parts that are standing, because once again, they have a very small base and they're making contact with the build plate, but we don't want to hit them in any characteristic of that, or we're going to potentially knock them over. And that's exactly what I did. This setting by itself, require minimum travel for retraction set at 3 millimeters, means that whenever we move 3 millimeters, and again, this is arbitrary, you could set it at 1 millimeter, you could set it at 0.5 millimeter, it will instantly trigger the retraction, in which case then daisy chains that effect and causes the extruder to elevate. And in turn of doing that, whenever it moved over to the next component, it would clear it, assuring that it would come down to make just printing contact rather than any potential contact from strings or any other material when it was jogging into location. So these are things to really think about. It took me a while to really figure this out and really play with it. I did some research online. Once again, many of you may know this already. I certainly did not. There's not a lot of detail on this when you want to move in terms of just elevating the head for jogging purposes and not to interfere with any componentry. There are the elevation factor, like we've seen here, where we can do retract vertical lift, but nothing to just set up the Z-axis so that it would elevate whenever it's going to travel to get to a new location to begin printing. That is a very critical setting I hope Simplify does actually implement, although this does work the same, so I don't know if they will. I mean, it might be more time and money to do that, but either way, you guys now know exactly these two settings exist and how to work them in conjunction to give you that elevation, excuse me, if you require it. Okay guys, the print is complete, and you can see what we got here. Let's see. These came out fantastic. Nothing fell, and you can see these standoffs look perfect. Now, for many of you, I don't know how everybody removes their prints, but when they're delicate parts or parts that you want to release, just fold the build plate and hold it. And you'll see most of them just release. Just hold it done, and you have no problems. And you also then don't have any problems with your build plate. And once again, you can really see on the Method stock build plate, we have no texture. This came out flawless. And that's what you guys should see. You should see just a light imprint from the glue, but there should be no texturing. Once again, let me grip the other build plate. Like the BuildTak from temperature. And again, this is what I'm talking about with that embossing effect, where you can actually feel the raised area. This we do not want. This we want. So once again, these stuck like glue, literally, and came out fantastic. The strength is excellent, and these standoffs are perfect. You can see that 0.1mm finish. They look great. Okay guys, I hope this has helped many of you. I'm trying to get a good camera angle there. Not to say that the BuildTak does not work, it certainly does, but I myself am not impressed with that. That bothers me because, like many of you, you're going to run a hotter temperature, especially when you're printing different filaments, and that will certainly cause issues down the road as you continue to print. Any embossing effect is definitely going to show its face when you try to have parts, especially with small bases like this, try to stand on end. And again, printing with just a model extruder, you need a flat laminate just as you do the build surface. So again, if this video has helped you, I really do appreciate it. If you guys could leave a like. Thank you all for your support. Take care.